Hello, this is Mike Rowland, and I'm here to talk more about my winder. Now, in the last videos, you may recall that I'm winding a multi-strand coil with many spools. In my case this time, it's going to be 24. So there's a certain amount of tension that has to go on each one of these, and then it goes down here to the main winder motor, which is right here. It's a little dark out tonight here, and I'm outdoors with my table, but I'm covered in case it rains. I have a canopy. So anyway, I built this box today. Now I don't know if you can see that box, but this is a current limiter box. What that does is it has a little load inductor on the right there. And this is a Variac, a 55 volt Variac, which is nothing more than a big potentiometer. It's like a big resistor. Let's see if I can get more light here. Here's the top of it. And I got it wired into an inductor right there. See my inductor there? And the object of this video is to show you something that slows down the motor. Why? So that it doesn't break strands. Okay, here's the spool. We'll hypothetically, we'll say that we're going to use this spool, and let me put my camera up so I can have both hands free. Hang on a second. Let's see how good I am at this. There. I think I got that on there. It won't fall off, right? Alright, here's the box. It's kind of dark. That box is kind of dark right here. But there's a Variac in there, and I showed that to you. And then the object is to, well, there's another way. There's more than one way I could create tension. A tensioner or a means of limiting the amount of tension so that I don't break strands. Now in this case, I'm just putting a shim, or I could slip this on here tight if this was all I was using. And it's already tight, see, right there. I could use that method, although that's not what I'm going to be using. I'm going to be using this right here. This one is going to be a C-core wound around, but I'm just giving you the idea with this, what I'm doing. I'm trying to limit. This is a gearbox driven motor, or it's a motor, I should say, with a gearbox over there. And this is a powerful device, so it will break all my strands if I allow it to. So one method is to just force your spool onto your shaft, right? And it will begin to slip if it gets too much tension. And so I'll give you an idea what I'm talking about. Now I've got some wire. Now I'll show it to you. Here. Now there, I got that. Now I've got some of this wire. You probably can't see it. It's 0.011 or 12 wire. It's that 29 gauge wire, and it goes. We'll say put it around here. We'll put it here, and it's going to turn this way, and it's going to go around this spool right here, for instance. Now the way I've got it right now is when you turn it on, it doesn't work unless you help it. That's how slow, that's how little current is going to that. And I'll show you in a minute. It's a 1.5 amp motor, I think it is, and it'll, now I'm going to turn it on. You ready? Nothing. All you'll hear is a bit of humming. Now I can turn this and it's barely going. You see that? Now you see I'm winding this up around there? Now watch, I'll slow it down. I'm not breaking the wire yet. See, it slowed down and quit, and it's stuck again. And until I help it along, there it goes. It's winding up again. See it winding up? I don't know if you can see it winding up or not. Right there? Yeah. It's winding up around there. But now let's say it gets stuck on something and it starts pulling. Okay, I'm grabbing the wire tighter. Now they don't take much to break these. I can break this real easy. This stuff is real soft, copper wire. But I don't want to break it while I'm winding. See, it's like thread. And it's still just humming away. And it's on. So what this is creating, what I've created is a safeguard against breaking my strands by limiting the amount of current with this box up here. And if I go the other way, I have to help it the other way too. It'll start going. Once it's going, it's fine. It's very hard to stop, but not impossible. As you've seen, I'm pulling some of this back off. This is just on there silly crooked, so you can see it, and there's wire coming on and wire going off. Now I'll stop and I'll go the other way. See it go the other way? Now if I pull on that wire, like something got stuck on my, say I got too much tension or something on there. But keep in mind, and it's off now. Once it goes off, that's it. So I have a means right here by adjusting this of let me get a light and show you. Hang on a second. I'd like to show you a little bit better shot of with more light. Here, how about that? Can you see it better now, or is that messing up? See if there's glare. Yeah, I guess you can see it. It's kind of hard to do lighting when you're not a pro, right? But you become proficient at it after a while. Okay, so this is the motor and gearbox, and it's real powerful. And if I need it to wind great big coils, that's fine. Now with this really fine wire here, now, that stuff breaks easy. And even with 24 of them coming this way, this won't be here. This is my, by the way, you can get a better shot. That's my inductor out of a pump, which is a 120 volt inductor out of one of those pumps. And I just sent it through there and then there next. And I got it almost all the way down. In this case it's reversed, but I barely got any power going to it, and it works fine because it's gear driven. See, if it wasn't gear driven here, I couldn't do this. It wouldn't work right with a regular motor. I couldn't get any tension on it properly. I wouldn't have any in-betweens, so to speak. But with this inductor, which creates a load, and this gear driven and this Variac, I didn't plan it that way, but that's just what I brainstormed, what I had on hand. Okay, now we'll go back here, it's on again. I think it's on again. No, it's not on right now. Okay, so it's off. And so you see the setup, how I've got to have 24 of these coming down to a coil so I can set right here the tension. So it does, you know, also another possibility is that I'm supposed to create some kind of, I could create a limit switch system. Now this is better than nothing, and having both might be a good idea. But let me move this box and show you what I'm talking about. For those of you who are serious builders and you want to make a winder, well, you've got to have a means of limiting your tension. Not only limiting your tension up here, you can create tension on each one of these spools. I've got that coming too, and I'll show you sometime. But you could bring your wire up and around. Just ignore this for now because I'm going backwards to show you, but you get the idea. I could go up and around this way and around that rod. Maybe you can't see it, I don't know. And then back again, and that would create tension right here just by going around rods like that. But there'd have to be a little turn wheel on it. And then I could put like a rod that floats like this up and down with a limit switch on it, so that if it got too much tension, that the wire would move a long ways. I'll move it this way for you. See, if the wire is like this normally, and then all of a sudden the tension starts getting too great and pushes this way, then it will limit switch. And that might be the best way. Put all 24 wires through a limit switch so that you don't break them. That's the problem. That wire is so fine, it's easy to break. So I wanted to show you the amp draw, but it's not that important. The amp draw can be seen at like 0.3 amps on the meter here. That's what it was at. So I knew that by turning it down, I'd really lowered the amperage so that it would stall. And that's what's been going on. I've been driving this so that it works just right, and it will stall if it gets too much tension on it. And I suppose I'll try it like that first. Okay. So that's what my update is for today in my winder. The winder needs to have more than just the mechanical ability to hold spools. It needs controls on it, so, or some kind of safeguard in it so that it doesn't break wire. And one problem I was having with that over there, this right here, I was concerned about that right there being so strong that it would break wire, especially this thin stuff. So I wasn't sure what I could do, because that is a gearbox motor. So I came up with this idea. Yeah, I came up with this idea to limit. You plug the motor, this motor, into there, and then this goes into the wall, and it limits and it's dialable so that you don't break off all your wires. And if you build a winder, there are many considerations. Not only do you want the winder to go back and forth, but you want to be able to tension, put a certain amount of tension on the wires, especially controllable, very finely controlled with such fine wire. But any wire really will break. We're working in the range of like 28 to to 20 gauge wire, somewhere in there. And when you get around 24, 25, 26 even, all those are pretty pretty small wires, depending on how you got it set up. But I think I'm pretty confident about not being able to, not breaking that. And these spools are very precisely set up. These spools down here at the end there, I've got these spools, all of them now, where they're tight. This way, they have an insert inside of each spool, has its own little bearing in there, and then also also there's a each spool has a cover that goes over there like that to hold it, and then there's a washer here, and there's a washer here, and there'll be a grommet, a small 1/4 inch grommet in between each one, and tension can be placed slightly on everything, but independent. The main thing that is important, I noticed, is that when you're putting one spool next to the other, it wants to, if one turns, the other one next to it will also want to turn. So you don't want that. You want this one independent of the next one. So as you can see, I've got like these grommets that slide on here. Now that's too big. I just do that for temporary winding. I'll face two together like this. Two of these claw tooth grommets. And I'll face them together like this, one on each side, and press it together with the collars. These are collars. And this will grab on there, and I can get it off quick with collars. And but that's what's been going on. I've been trying to figure out the best way to keep them independent. See, in the past, if I put two spools together, one turn, the other one turn. So I had to create a system where one spool is isolated from the other. So what I have in mind, I've got these grommets coming in the mail, and of course everybody knows what a washer is, so you put a washer there, and then you put a grommet, and in this case it wouldn't be that thick, it would be more that real thin area, about 1/4 inch thick. The grommet would go on there tightly, and then the next spool would go on like that, and when this one turns, it wouldn't turn that one too. They would be separate from one another, and that's important. But still, there needs to be a bearing on each one, and I've got all these cut too, all these little plates, and so I pretty much got everything, and I'm winding the last of my. So you create a little bit of inward tension on the whole set of spools, and there's a little bit of tension on each one, right? But wouldn't be floppy like that. It'd be held tight like this and nice and straight like that, but independent of one another. And then from there, I have to have it come up through a hole. Each one has to come up through its own hole, and then finally down to this hole. So I have to get some funnel shaped eyelets. I have to make something that's funnel shaped, so all the lines that come together are not catching on one another or catching on something. It has to have the right size hole and the right amount of tension, and yet still not break. I I don't want this overpowering or muscle with so much muscle that if I get